This video or PowerPoint is about significant figures and counting significant figures. This is one subject that gives a lot of students fits, but it shouldn't have to be that difficult. Remember, in a previous lecture, we discussed how scientists report numbers and what that means. So, in the same sense, we're going to talk about how to interpret these numbers and determine how many significant digits there are and where numbers leave off in terms of their significance, indicating the level of precision a measurement has. One of the big areas that people struggle with are zeros, and anytime we have trailing zeros, they're typically not significant unless we have a decimal point. So in this first number, the 756,000 here, we can guarantee that we can measure in the hundreds, thousands, the 10,000s, and thousands, but we're not entirely sure whether we can measure in the hundreds, tens, or units place. So we can guarantee that the first three digits are significant, but we don't know the amount of measurement corresponding to the digits that have zeros. So we'd say that this number has three significant figures. But once we introduce a decimal point, then the whole game changes here. If I have the same number and put a decimal point after all of those zeros, that means that I've been able to measure it down to the single digit. It just so happens that the hundreds, tens, and ones places are occupied by zeros in the measurement that we made. I can really push it out here, and if I have that decimal point and a couple of additional decimal points beyond that, then what we can say for that last measurement is that we have 8 significant figures. Leading zeros are another area where students get confused. Leading zeros are never significant. They're just placeholders. We would never write 756 with leading zeros because we have no measurements in those numbers. So there are no thousands measurements, 10,000s measurements, or 100,000 measurements for this number 756. We would never say 0 100,000, 0 10,000, 0 thousands, 756. It's just not done. Since there's no measurement in those leftmost positions, we don't even mention them, so they're not significant. In the same sense, if I have a small number, a fraction expressed as a decimal, and I've written it with leading zeros, those leading zeros are just placeholders until we get to a significant digit. So I would have 3 sig figs in that example as well. So I forgot to click through this. So I've got 3 sig figs there. I've got 3 sig figs in that number. I've got essentially the same number, but I have included a trailing 0. But because there's a decimal point, that makes that 0 significant. So there would be 4 sig figs in that number. Sandwich zeros are always significant. If I'm able to measure down to the last digit, I certainly can measure to the digit before it. So in this case, I can read to the tenths of whatever these units are. I have a 0 in the hundredths place, but because I have a thousandths place, I have a non-zero digit in the 10,000ths place. So that must mean I can read that thousandths place digit. So I would say that I have 3 sig figs. Likewise, in this large number, 700 or 70,600, I've got a 0 between the 10,000s place and the hundreds place. I could measure it. It just happens that that digit in the thousands place is just 0. There's no decimal point, so those trailing zeros aren't significant, and that would mean that this number has 3 significant figures. Exact numbers are another area where students sometimes struggle. If I have exactly something, I have no more or no less, and it doesn't vary. So if I have exactly 3 bananas, I've got exactly 3 bananas. And I don't have 3 and a tenth or anything. I just have 3 complete bananas. So anytime you're talking about dividing, there's 3 pies and they each have a given mass. If I'm dividing by 3 pies, that 3 is exactly 3 pies. Conversion factors, a lot of them are exact numbers. For instance, 1 mile is exactly 5,280 feet by some previous definition hundreds or thousands of years ago. So it doesn't vary. On Wednesdays, it's not 5,281 feet. It's always 5,280 feet exactly. The same with the relationship between inches and feet, hours and days, minutes and hours, pints and ounces, liters and milliliters. Anytime I have something that is clearly defined and or sometimes stated in a problem that it's exact, so look for the word exact in problems as you're working them. That would indicate that you're dealing with a relationship that has an exact relationship, and the way I treat these are as if they have an infinite number of significant figures. So any exact relationship is not going to limit the number of significant figures in a calculation.